Hello friends and my dear students, I welcome you all to my channel. So this is the new playlist that I have started where I will discuss mathematics of class 7 from the ICSE board following the textbook of ML Aggarwal. This is the first video, part 1 video on the chapter of integers where I will discuss about this video will be based on a review of integers where I will discuss about the various types of integers, that is the various collections of integers, the absolute value of an integer and how we compare integers and the number line representation of integers. So if you are watching this video for the first time or if you are new to my channel, then I strongly suggest and request that you please subscribe to my channel so that you will be notified by my future videos. I will in this playlist I will thoroughly follow all the topics covered in the textbook of ML Aggarwal and will solve all the problems at the end of the exercise, at the end of each chapter, exercise problems, and also the check your progress and mental ability test. So I will solve all the exercise problems from the textbook, and parallelly I will also I will also make videos in another playlist, that is Maths 7 Hot, where I will discuss and solve relatively harder concepts and problems of mathematics of class 7 based on the ICSE board. So also please watch my videos in that playlist. Okay, so let's start the part 1 video on the chapter of integers. Okay, so I have whenever I will discuss any topic from any chapter, I will have a quick notes as a reference on the left hand side. So based on the quick notes will have all the topics that I will discuss in a particular video, and these quick notes will grow as and when I will progress with the chapter. On the right hand side, I will discuss and explain the concepts and solve any problems. So for every video where I will discuss any particular topic of a chapter, I will solve few problems to as an example problems to illustrate how the concepts learned from the topic is to be applied to solve any problems. Okay, that problem solving I will do at the end. Okay. So this video is about integers, review of integers, where you already know whatever I will discuss in this video you are already familiar with, you have already learned in your previous class, that is class 6. Okay, so what are the various types of integers or the various collections of integers or sets of integers? You are already familiar with the chapter of set theory. You have learned set theory in your class 6. A set is a collection of well-defined distinct objects. So the integers, all the integers values can be have different sets. Sets of I mean there are different sets that contains different types of integers. So please follow the notes on the left hand side. So the first set is the natural numbers, that is denoted by the capital N. Capital N denotes the set of natural numbers, which means that contains all the natural numbers. Natural numbers are counting numbers, that is it has the numbers 1, 2, 3, 4, 5, 6, 7, 8 like this, and it is an infinite set. Now, so we have a natural number is 1, 2, 3, 4. This way somewhere we will have 500, and please note that the three dots where the three dots mentioned in a set means it represents a large collection of numbers. It represents a large collection of numbers. So so after 4 and all the elements in a set are separated by commas. So if we have, so I am writing the set of natural numbers like this. The set is starting from the element 1 we know that natural number starts from 1, and the next subsequent natural numbers are 1, 2, 3, 4, 5, like this. Now after 4 I have written 3 dots. This means that after 4 and before 500 there are many other natural numbers. That is specifically between 4 and 500 there are natural numbers from 5 to 499, and after 500 I have written dot dot dot. This means that any set, whenever in a set you have if a set, this is a roster form of set. You know, there are two representation of set, a set builder and the roster form. So this is a roster form, a representation of a set. The last 3 dot means that there are infinite number of more natural numbers after 500. So definitely the natural numbers is an infinite set of the integers which are 1, 2, 3, 4, 5, 6, like this. And so in this set, as you can understand, that any element in this set is one more than its previous one, and it is less and it is one less than its subsequent integer. Okay, so this is the set of natural numbers. The whole numbers is the set of all the natural numbers plus the integer 0. So we have 0, and then we have 1, 2, 3, 4 dot dot dot, meaning there are many more integers between 4 and 500, and then dot dot dot. Now in set notation, we say that the whole numbers is the set of natural numbers plus the integer 0. So this can also be written as a single set, a set having the single element 0 union the natural numbers. I hope you are familiar. So any side, any concepts related to any concept that I will discuss, I will write that on the right hand side. So I hope you are familiar with the set operation. Like, let's say if A and B are two sets, A union B, this the U symbol is for union. That is, this set A union B will have elements from both A and B. Similarly, this is known as A intersection B, meaning the set A intersection B will have only the elements which are common to both A and B, So the set of whole number can be, since whole number is nothing but the collection of the set of natural numbers plus and the number 0. So I can write W as the set having the single element 0 union n. Okay. Then is the set of, so these are the standard symbols used in mathematics for representing the various collection of integers. Capital N is for natural numbers, W is for whole numbers, and Z plus is for all positive integers. So these are positive integers, that is 1, 2, 3, 4, like this, 500 and dot dot dot. Remember that the Z plus, as you can see, Z plus is nothing but it is equal to the natural numbers. So positive integers and natural numbers, they represent the same set. Okay. Then we have the negative integers. It is represented by Z minus. The negative integers, as you know, it is nothing but all the negative integers. Now dot dot dot, meaning there are many more negative integers to the left hand side, and we have like this: -6, -5, -4, -3, -2, and -1. So these are the negative integers. It ends with, the set of negative integers ends with the -1, but it is an infinite set, as it has many more infinite number of integers before -6. And the Z plus is the set of positive integers. It starts from the, basically it is the natural numbers. It starts from 1 and there is no end. It is an infinite set. So all these sets are infinite sets. Okay. Now remember, please note that 0, the integer 0 is neither a positive integer. The value 0 or the integer 0 does not belong to any of the sets Z plus or Z minus. So 0 is not a positive integer and 0 is also not a negative integer. This is a very important or critical concept that you must understand, that 0 is not a positive integer and it is also not a negative integer, but it is an integer and it is a whole number, but it is not a positive integer and it is also not a negative integer. Now what are integers? So we have the set integers is denoted by the letter Z. Z is nothing but you can say Z plus union the 0 and union Z minus. That is, you take all elements from, you take all the negative elements, you take all the positive elements and the integer 0. So this is the set of integers. Okay. Fine. Now another two very important concept you must also be very clear is that what are non-positive integers. Now I am not sure what letter is used to represent the set of non-positive integers. Let's say non-positive for the sake of discussion. Let's say I am using the two letter abbreviation non-positive. Let's say NPZ. Let's say, even though in mathematics a set is always represented by a single letter, just for the sake of discussion I am using this abbreviation NPZ to represent the non-positive integers. Now what are non-positive integers? Non-positive integers are the set of integers. First of all, what is a non-positive integer? A non-positive integer is an integer which is not positive. Now, which is not positive. So definitely all the negative integers will be non-positive and also 0 will be non-positive, because we know that 0 is neither a positive integer nor it is a negative integer. So a non-positive integer, so non-positive, let's say I am non-positive integers will be all non-positive integers will be all the negative integers, that is Z minus union the integer 0. Now remember that this is a set of with one element having with one element which is 0. Okay, so this is the non-positive integers, that is all the negative integers and 0. So basically this is, as you can see, this is dot dot dot, meaning there are many more negative numbers to the left hand side, and let's say -4, -3, -2, -1 and 0. So non-positive integers. A non-positive integer means it is all the negative integers including the 0. These are non-positive integers. Okay, then is the let's say I am abbreviating the non-negative integers NNZ. NNZ, let's say, is I am abbreviating the non-negative integers as NNZ. So what is a non-negative integer? A non-negative integer is an integer which is not negative. The simple definition is that a non-negative integer is an integer which is not negative. Now what are the integers which is not negative? Obviously all the positive integers are not negative, and also 0 is not negative. As I said, 0 is neither negative nor positive. So definitely this set will be 0 and then all the positive integers. Essentially, you can say that the non-negative, alternatively, the non-negative integers is basically the whole numbers. You can say the whole numbers is basically the non-negative integers. Okay, so these two concepts is also very important. Non-positive integers and non-negative integers. These two terms, these two concepts will be heavily used in higher classes like especially 11 and 12. And the set theory is also one very important chapter. You must understand it very clearly because it will be heavily used in class 11 and 12 mathematics. And also you have probably you have set theory in your higher classes like class 8, 9 or 10. Okay. So these were the standard collection of integers. The natural numbers, that is the counting numbers 1, 2, 3, 4, 5, 6, 7, 8 and so on. The whole numbers, that is the natural numbers plus the integer 0. The positive integers, that is basically the natural numbers, that is the 1, 2, 3, 4, 5, 6 and so on. The negative integers is basically the negative integers z minus, integers z, that is all the elements, all the numbers from z plus and z minus, that is the collection of all positive and the what is z? Z is the collection of all positive and negative integers and plus 0. Now I think yes, this one. So what is z? Z is the collection of all positive integers and the negative integers as well as 0. Okay. Then is the non-positive integers. A non-positive integer is a integer which is not positive. So what integers are not positive? It is the 0 and all the positive integers. So it is so it is non-positive integers is nothing but the z minus union the that is you include 0 in the set of negative integers, it will be the non-positive integers. And non-negative integers is an integer which is not negative. So all positive integers and the integer 0 are non-negative integers. So non-negative integers is basically the z plus, that is all the positive integers union the integer 0, which is also equal to the whole numbers. Okay. So these were all the various collections or sets of integers. Now some important information you must be well aware of, that all these sets are infinite sets. That is, the number of elements in this in all these sets is infinite. That is countless. There are unlimited number of natural numbers, unlimited number of whole numbers, unlimited number of positive numbers, negative numbers, integers, and non-positive integers and non-negative integers. So all these sets are infinite. So minus 1 is the greatest negative integer. So as you can see, the negative integers, as I said, the negative integers ends with the number minus 1. And before minus 1 we have minus 2, minus 3, minus 4, minus 5, minus 6, and before minus 6 there are infinite number of countless number of negative integers. So there is no end, there is no starting point, there is no starting element of this set z minus. So there is no you can say there is no least negative number, but the greatest negative number is minus 1. Okay, 1 is the least positive integer. As you can see, the positive integers start from 1 and then we have 2, 3, 4, 5, 6 and so on. There is a countless number of integers, but this set starts from 1. So the least value the least positive integer is 1. Okay, 0 is the greatest non-positive integer and 0 is the least non-negative integer. This is also very important. As you can see that in the non-positive integer, not in the set of non-positive integer, this set is ending with the value element or number 0, and before 0 we have all smaller values, that is -1 is less than 0, -2 is less than -1. We have smaller values to the as we progress to the left of this set. So so 0 is the greatest non-positive integer, and 0 is also the least non-negative integer. As you can see, the set of non-negative integers, this set is starting from the value 0, and all the subsequent numbers of this set are greater values. As you can see, it is 0, 1, 2, 3, 4, 5, 6 and so on. So 0 is obviously the least non-negative integer. Okay, now there is no least integer. As you can see, as we know that the set of integers we have there is the set of integers is an infinite set. So z, we know what is z. Z is something like this. We have dot dot dot, and let's say we have a minus let's say minus 500, and then dot dot dot. No, let's do it this way. So we have dot dot dot, meaning there are infinite number of more elements to the left hand side, and let's say we have minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, dot dot dot. So this is the set of integers. As you can see, since this set there is no left, there is no end, there is no end to the left hand side, and also there is no end to the right hand side. So this set, the set of integers will do not have a least number, and it also do not have a maximum number, because as you proceed to the right hand side you will have greater values, and as you proceed and you progress to the left hand side in this set, if you progress to the left hand side you will have lesser values. So there is no least and greatest integer. Okay. Also there is no integer between two consecutive integers. So definitely this is very obvious. Between any two consecutive integers means if n is an integer, then if n is any integer, then it's so n and n plus 1 are consecutive integers. Also if n is any integer, then n and n plus 1 are consecutive integers, and between n and n plus 1 there is no other integers. Also I can say that n minus 1 and n are two consecutive integers, and between n minus 1 and n there are no other integers. Okay. The last point says there is at least one integer between two non-consecutive integers. So if there are two integers, let's say x and y, if there are two integers, let's say x and y, and these two are non-consecutive integers, then obviously you will have at least one integer in between them. So if x and y are non-consecutive integers, then I can say that between x and y there is at least the number x plus 1, where obviously x and x plus 1 are two consecutive integers. So x plus 1 will at least the number x plus 1 will be there between x and y. There could be more than one integer between x and y, depending on the value of x and y. Okay. Okay. So these are some points that you must understand and keep in mind regarding integers. Okay. Now let's see how we represent integers on the number line. So I have on the left hand side in the quick notes, there is a number line, you can see, and I have there is some markings. The integer 0, so we have the center the center, the point O. So above the line, any point is marked by some letters, capital letters, and the capital letter O, which is at the center of the number line, represents the value, integer value 0. And to the right hand side, so we see point wise, the origin O marks the integer 0. All positive integers, that is the natural numbers, that is the numbers 1, 2, 3, 4, 5, 6, and so on. All these positive integers are marked to the right hand side of the origin, and all the negative integers are marked to the left hand side of the origin. So the points G, H, I, C, D, they are all positive integers, and the points F, E, B, A, they are all negative integers. Specifically, you can see that the point G represents the integer, positive integer 1, H represents 2, and I represents 3. Similarly, the point F represents the negative integer -1, and E represents the negative integer -2. Okay. All integers have a unique position on the line. So if you are given an integer, then that integer will have a unique position in the number line. So if you have a number line, let's say this is the number line, this is the origin O, which represents the value 0. Let's say there is a, let's say this point A represents the integer n. Obviously, since the A is to the right hand side of O, n is a positive integer. Now is a positive integer. Okay. Now if you are asked to, let's say so it says that all integers have a unique position on the line. So if you are if you are asked to mark the integer value n plus 1 or any other number, which is let's say not n, let's say if you are asked to mark the point m which is not equal to n, then m the position in the number line m cannot be the position of A. That is, m cannot be marked at position at point A. Also at point A. So every unique integers has a unique position in the number line. So let's say so the idea is that let's say P and Q are integers. Let's say P and Q are integers, where let's say P and Q are integers, let's say marked by points A, points A and B on number line. So if P is not equal to Q, this will imply that A and B are different points. Different points means different position on the number line. And if P is equal to Q, this implies A and B are same points. Same points on the number line means the same position on the number line. So this is the basic idea. Okay. Now an integer x marked on the number line is at a distance d from origin O, where d is the numerical value of x. So let's say, so what is it saying? That an integer x, so if x is an integer, it will be marked on the number line at some position. So the distance of that point on the number line from the origin O, if the distance is d, then what is d? D is nothing but the numerical value of the integer x. Now what is the numerical value of integer x? Numerical value of integer x means you just take the value, you ignore the sign. So let's say if let's say I'm having a number line, so this is the origin O 0. Let's say I have, let's say the point A represents the number 4. Let's say the point B represents the number -6. Let's say the point C represents the number -3. So the distance of a point. So if so, we must have so a distance of A from O is equal to 4, because the point A on the number line represents the integer plus 4, represents the integer plus 4. This is plus 4. You can say distance of A from O is you can say numerical value is also termed as the absolute value, which I will discuss a little later. So numerical value of plus 4, which is equal to plus 4. So also let's say, so what will be the distance of C from O? See, the distance of C, the distance of the point C from O will be equal to the numerical value of -3, which is equal to 3. So the distance of the point C, which represents the value integer -3, the distance of point C from the origin O will be the numerical value of the integer represented by the point C. So the point C represents -3 and the numerical value of -3 is 3. So distance of C from O is 3. Similarly, distance of B from O, that is the origin O, is equal to numerical value of -6, since B represents the integer -6. Now this is equal to 6. Okay. The next is between two integers x and y, where x is less than y, there are y minus x minus 1 unique integers. So this is also a very important concept, that between any two integers, how many integers are there. So always, so the formula is that if x is if given two integers x and y, where x is less than y, then how many integers are there between x and y? It is y minus x minus 1. So let's say how many integers are there between between -3 and 4, there are 4 minus of -3 minus 1, which is equal to 4 plus 3, 7 and 6 integers. So the formula is y minus x minus 1 is the number of integers, unique integers between x and y. Now what does it mean, integers between x and y? The integers between x and y do not include the integers x and y, that is all the integers that is greater than x and less than y. Also let's say between we can say 4 and 10 there are how many integers? 10 minus 4 minus 1 or 5 integers. There are 5 integers. Also, let's say between minus 9 and minus 3 there are here y is minus 3 and x is minus 9. So minus 3 minus of minus 9 minus 1 or this will be minus 3 minus 3 minus minus 9 is 6. This is 5 integers. This is 5 integers. So between 3 and 4 the integers are minus 2, minus 1, 0, 1, 2, 3. If you count them 1, 2, 3, 4, 5, 6, there are 6 integers. Now between the integers 4 and 10 the integers are 5, 6, 7, 8, 9. If you count them there are 5 integers. And between minus 9 and minus 3 what are the integers? They are minus 8, minus 7, minus 6, minus 5 and minus 4. If you count them there are 5 integers. Okay. Let's see the next point. Distance between two integers x and y on the number line is y minus x. So if you are asked what is the distance of the two integers, let's say 4 and 6 on the number line, so it will be 6 minus 4. So distance of so let's say, let's take some example. Let's say there is a number line. This is the origin 0. Let's say we have some integers marked by the points. Let's say this is 1 and let's say this is 2. This is 2. Let's say this is 3. This is 4 and this is 5. Similarly, let's say this is minus 1. This is minus 2, minus 3 and minus 4. Okay. Now let's mark some points. Let A be the point. A marks the point. The point A marks the integer 2. B marks the integer 5. Let's say C marks the integer minus 3. D marks the integer minus 4. Okay. So what will be distance? So distance between. So all this concept of distance, that is the distance of a distance of a point, distance of a point on the number line, marking an integer from the origin. So these are all based on the number line. So distance between, let's say if I ask the distance between minus 3 and 2 on this number line will be equal to 2 minus 3 which is equal to 5. So as you can see the distance between minus 3 and 2. So we have if you see now what is this distance? So how many jumps you have to make from the number minus 3 to reach the number 2. So if you see 1, 2, 3, 4, 5. So you can see 1 jump, 2 jump, second jump, third jump, fourth jump and fifth jump. So basically when the distance between two integers x and y, where x is less than y, is the number of jumps you have to make on the number line to reach from x to y, or it is the value y minus x. Similarly, distance between, if you see, minus 1 and 5 is equal to 5 minus of minus 1, which is 6. That means from the number minus 1 to reach the number 5, you have to make 6 jumps to the right on the number line. So this is the meaning of the distance between any two integers on the number line. Okay. The next is larger positive integers are marked farther right of origin. So this is a very simple concept, that to the right hand side, we know that to the right hand side of the origin O, we mark the positive integers, and the larger positive integers, the larger positive integers or the greater positive integers are farther away, farther right of the origin, that is, are farther away from the origin. Similarly, the lesser negative integers, the smaller negative integers are farther away from the origin to the left hand side. So it says that larger positive integers are marked farther right of origin O, and smaller negative integers are marked farther left of origin O. Okay. So that was about how we represent integers on the number line. Let's see next what is the concept of absolute value of an integer. So just now I explained about the numerical value of integers. So the numerical value of an integers and the absolute value of an integers, they have the same meaning. So what is an absolute value of an integers? So an absolute value of an integer, so if a is an integer, then we use a vertical bar to the left hand side and the right hand side. This denotes the absolute value of a. So this is the notation, mathematical notation of the absolute value of writing the absolute value of an integer a. Now what actually is, if you are given an integer a, what will be its absolute value? How do we define it? How do we find it? So the definition says that absolute value of a will be equal to a if a is a non-negative integer, that is, if a is greater than equal to 0. Any integer which is greater than equal to 0 means it is the integers. It can be the integers 0, 1, 2, 3, 4, 5, 6, which is basically the non-negative integer, and the absolute value of a will be minus a. So definitely the absolute value of a will be minus a if a is a negative integer. So this is a mathematical way of defining the absolute value of a, and the concept is very simple. So absolute value of minus 1 is 1. Absolute value of minus 2 is 2. So whatever the integer is inside the absolute value, absolute notation, you just in that integer you just ignore the sign and take just the numerical value. Now things might get a little confusing if you have something like this, minus of minus 2. Now what is this? What will be the value? Remember that the absolute value of any integer is either 0 or a positive integer. So which means that it is always a non-negative integer. So absolute value of any integer is always a non-negative integer, that is, its value is always greater than or equal to 0. Okay, so now what will be this? So inside the absolute notation, inside you may have a single integer, or you may have some expression, that is multiple integers may be there with some operation, addition or subtraction or multiplication. So so inside the absolute notation, absolute symbol, there can be a single integer or there can be some expression. So these are, in these two examples, we are having inside the absolute symbol only single integer, that is -1 and -2. But for this example, in the inside the absolute symbol, we are having not actually we are not having a single integer. This is a small expression. And the expression is negative of -2, and you know that this is nothing but 2. So obviously this will be 2. Okay. Now regarding addition and subtraction, I will not of integers, I will not discuss in this video. I will discuss in the next video. So I hope it is clear what is meant by the absolute value of an integer. Now few points to keep in mind regarding absolute value of integer. So as you can see on the left hand side, it says that the basic concept in words is that the absolute value of a is the numerical value of a. That is, if a is an integer, you just ignore the sign, take only the numerical value, that will be the absolute value. And okay, next, absolute value is always a non-negative integers. Is a non-negative integer, that is an integer which is either 0 or greater than 0. That is, absolute value of integer a can be value 0 or the values or the positive integers, that is 1, 2, 3, 4, 5, like this. Absolute value will never be a negative value. Absolute value will never be a negative integer. It will always be either 0 or positive integers. Okay. And this next one is that absolute value of a will be equal to the absolute value of negative of a for any integer a. This is quite obvious, because let's say absolute value of -3 is equal to absolute value of 3 is obviously equal to 3. So the absolute value of an integer a will be equal to absolute value of the negative of that integer a. Minus a is the what is minus a? Minus a means the negative of integer a. Okay. Then it says that if absolute value of a is 0, it will imply that a is 0. A is 0. So absolute value, if you have if you have something like this, that absolute value of a is 0, this will always mean that the integer a is equal to 0. So you can alternatively, I can say that the only integer for which the absolute value of that integer is 0 is 0. So the only integer for which the absolute value of that integer is 0 is the integer 0. No other integer other than 0, its absolute value will be equal to 0. So only for the integer 0, we have absolute value of 0 is equal to 0. Okay. The next is that it says that mod a, if you have something like that absolute value of a is equal to absolute value of b for some integers a and b. Let's say a and b are some integers, and if you have if you know that this is true, that absolute value of a is equal to absolute value of b, then it does not necessarily mean, by this I mean it does not imply. I am not sure whether this is a standard mathematical symbol, whether this we know that this means imply, and whether this means does not imply, I am not sure of that. Anyway, for the sake of discussion, let's say this one, that is a striked implication symbol, means does not imply. So this will does not imply that a is equal to b. Why? Consider that -2, absolute value of -2 is 2, and this is also equal to absolute value of 2 is 2. But you can see that this is a and this is b and they are not equal. Minus 2 is not equal to 2, but I have absolute value of minus 2 is equal to absolute value of 2. So if you have absolute value of A equals to absolute value of B, this does not always mean that A will be equal to B. A will be equal to B. Okay. The next is that if you have some, let's say if X is an unknown variable, and if you have something like this, then mod of X is equal to mod of A, where A is some integer, and obviously mod of A will be a positive integer. So if you have something like this, A is a constant integer, it is known, but X is an unknown variable, and if you have this kind of equation, or if you have this kind of result that mod X is equal to A, and you have to find what will be the value of A. In this case, X will have two values. Now this also does not imply that X is equal to A. I mean, X is equal to A is not the only X equal to A is one solution of the equation mod X equals to mod A is one solution, but it is not the complete solution. So if you have mod X equals to A, mod X equals to mod of A, this will imply that X is equal to A or X is equal to negative of A. X will have two possible values, either A or negative of A. Let's say I have mod of X is equal to mod of minus 9. Now mod of minus 9, mod of let's say, so we have mod X is equal to minus 9. So what will be the value of X? In this kind of equation where we have mod, that is mod X is equal to, on the right hand side of this equality sign, it will be any positive constant. It need not be mod of minus 9. It will be any, it can be any positive constant integer. So what will be the value of X? X will always have two possible values. This will imply that X is equal to 9 or X is equal to minus 9. In general, let's say I have an equation like this, mod X is equal to K, where let's say K is a non-negative integer, that is K is the integer and K is greater than or equal to 0. This will imply if we have mod X is equal to K, where K is some non-negative integer, that is K is an integer and K is greater than or equal to 0, this will imply that X is equal to K or X is equal to negative of K. Example, if we have mod X is equal to 4, this will imply that X is equal to 4 or X is equal to minus 4. Okay. The next one is it says that mod of A multiplied by B, if A and B are two integers, so mod of A multiplied by B is equal to, you can separate out the mod, that is this will be mod of A multiplied by mod of B, mod of A multiplied by mod of B. For example, mod of minus 4 multiplied by 2 is equal to will be equal to mod of minus 4 multiplied by mod of 2. If you, so what is mod of minus 4 multiplied by 2? Minus 4 multiplied by 2 is minus 8. So this is mod of minus 8, which is equal to 8, and this is also, this is mod of minus 4 is 4 multiplied by mod of 2 is 2, this is also equal to 8. So mod of product of two integers a multiplied by b, and if you take the absolute I am saying the word mod in this symbol. This is basically absolute value of x, and we also refer it as mod of a. That is the mod of a. Mod of a is also sometimes the absolute value of a is also sometimes referred to as the mod value of a or mod of a. So whenever I will be saying mod of a, it means that the absolute value of a. So the numerical value of an integer, the absolute value of that integer, and the mod of that integer means the same thing. Okay. The next is that if you have an integer a, if a is an integer, mod value of a, if you a mod value of a greater than 0, this will not always imply that a is greater than 0. So if you know that mod value of a is greater than 0, then it is not the case that a will also be greater than 0. A can also be less than 0. For example, I know that a mod of 3 is greater than 0, because mod of 3 is nothing but 3. Also, I know that mod of minus 3 is greater than 0, because mod of minus 3 is 3 and 3 is greater than 0. But you see that in this case a was 3, which is greater than 0, which is fine. But in this case a was minus 3, which is less than 0. This is greater than 0, but this is less than 0. So mod of an integer a, if its value, the absolute value of an integer a, if the absolute value of an integer a is greater than 0, this will not always mean that a is also greater than 0. A can also be negative. A can also be less than 0. Okay. Another important concept is that if you have, let's say, a1, a2, a3, an are some integers, and if you have the sum of the absolute values, of some integers is equal to 0, it will mean that all those integers are 0. Let's say we have 3 integers a, b, and c, and if I have mod of a plus mod of b plus mod of c is equal to 0. If I have this result, if I know this, if this is true, that for some integers a, b, and c, mod of a plus mod of b plus mod of c is equal to 0, this will always imply that all these integers has to be 0. All these integers has to be 0, because you can, if you think a little bit, you can easily understand that when can the sum of 3 integers, if you consider absolute value of a, absolute value of b, and absolute value of c, these are all positive integers. We know that absolute value of an integer is always a non-negative integer, that is, its value is always greater than or equal to 0. So if we have absolute value of a plus absolute value of b plus absolute value of c is equal to 0, this will obviously mean that the absolute value of a is equal to 0, absolute value of b is equal to 0, and absolute value of c is equal to 0, because the absolute value is never negative. So now if absolute value of a is 0, it means that a is 0, as I have already explained little earlier, that absolute value of a equals to 0 implies, it means that a is equal to 0. Okay. Now this result can be extended to any number of integers. I have explained this with 3 integers a, b, and c. So if you have more than any number of integers, that is, if you have absolute value of any number of integers, so if you have, let's say I have n integers, I am denoting those n number of integers as a1, let's say a1, a2, a3 up to an, there are n integers. If I have mod of a1, that is absolute value of a1 plus absolute value of a2 plus absolute value of a3 plus dot 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 plus the absolute value of an is equal to 0. This means that there are n integers a1, a2, a3 up to an, and the absolute values of all those integers is equal to 0. That is absolute value of a1 plus absolute value of a2 plus absolute value of a3, like this up to absolute value of an is equal to 0. This actually means that all the absolute values will be equal to 0. This is equal to 0. Like this, I have absolute value of an equals to 0. This again implies that a1 is equal to 0, has to be 0. If absolute value of an integer a is 0, then obviously the integer a is 0. This is 0. An is equal to 0. Okay. Okay. The next 2 point is also very conceptual. It is very heavily used in higher classes. I will recommend that even if you if for some reason if you cannot understand this the last 2 concepts, that is mod x greater than a and mod x less than a, if you cannot understand this, that is fine, but I will highly suggest that you please try to understand these 2 points. That if let's say x is an unknown integer, x is an unknown variable, and we have mod of x greater than a, where a is a constant integer. A is some integer whose value we know, it is a constant integer. Now if this is true, that for some unknown variable x, where x for an unknown integer x, if this is true that the absolute value of x is greater than a, this will imply that so what can we say about the value of x? If we know that the absolute value of x is greater than some, now a is obviously a positive integer, a is obviously a non-negative integer. This is a non-negative integer, which means a is greater than equal to 0. A is non-negative integer. So if we have this kind of equation, or if we have this kind of, this is known as the inequality. The greater than sign is the inequality sign, which means that it is saying that the absolute value of x is greater than a. Now if this is true, then what we can say about the value of x, where a is a constant integer but it is a non-negative integer, that is its value is greater than equal to 0. We can say about x is that x can have values. So we can say that x is either any value greater than a, or x is a value whose value is less than minus a. For example, mod x greater than 4 will imply that this means, what can we say about the value of x? X can have value greater than 4, or x can have value less than minus 4. That is, x can be, the value of x can be 5, 6, 7, 8, 9, 10 and so on, or the value of x can be minus 5, minus 6, minus 7, minus 8 and so on. Okay. The other thing is that, so this was absolute value of x greater than a. Now when we have something like this, that absolute value of x is less than a, where again a is some non-negative integer, that is its value is greater than equal to 0. A is a constant integer and it is a non-negative integer, that is its value is greater than equal to 0. Now when we have this, if this is true that absolute value of x is less than a, this will imply, so what can we then say about the value of x? Then the value of x will be any value between minus a and a, that is x will be greater than minus a, and remember this is and x less than a. That is x will have, I hope you are familiar with this kind of inequality, this kind of you can say relation that this means that the value of x lies between minus a and a, where a is some non-negative integer. That is, the value of a is an integer and its value is greater than or equal to 0. For example, if we have mod x less than 1, this will imply that x is greater than minus 1 and x is less than 1. That is, we have this. The value of x lies between minus 1 and 1. Let's say mod x, if we have mod x less than 10, this will imply that x, the value of x will be greater than minus 10 and the value of x will be less than 10. That is, the value of x can have value anywhere between minus 10 and 10. That is, the value of x will be any value which is greater than minus 10 but less than 10. Okay, so this was about some concepts about the absolute value of an integer. The next topic is comparing integers, comparison of integers. How do we compare integers? That is, how do we compare two integers and say which one is greater or which one is smaller? So the fundamental, so to understand to understand the comparison of integers, we must know the very basic concept, and they are that all negative integers are less than 0. All negative integers are less than 0. So negative integers are always less than 0. All positive integers are greater than 0. That is, all positive integers, that is, any positive integer is greater than 0. Okay. So we can say, so if we want to have an arrangement of the positive integers, negative integers and 0, we have negative integer will be the least, and then we have the 0, as 0 is greater than negative integer but 0 will be less than positive integer. Okay. Related to the number line, on the number line all integers marked to the right of x are greater than x. So this is a number line interpretation of comparing integers. So on the number line, let's say this is the number line, and we have a point A, and let's say we have a point B, and let's say we have a point C. So it says that on the number line all integers marked to the right of x, let's say this be x, this be the point x. So on the number line all integers marked to the right of x are greater than x. So based on this number line, I can say that b will be greater than x, and I have d is also greater than x, and x is greater than c. And I can say b is greater than c, and I can say d is greater than c, and d is greater than b. Similarly, on the number line all integers marked to the left of x are smaller than x. That is, I can say c is less than x. I can say x is less than p. I will say it must have b less than d. So this is the understanding of comparing integers based on the number line. Okay. Now, if we are given two integers a and b, what is the mathematical way of finding which one is greater or which one is smaller? So how do we compare mathematically two integers a and b. So there are some rules. There are fundamentally three rules that we apply or use to identify between two integers which one is greater or which one is smaller. So the rule one says that if integer a is less than 0, that is if a is a negative integer and b is a non-negative integer, so rule 1 is that a is less than 0, which means that a is a negative integers, and we have b greater than equal to 0. Now this means that b is a non-negative integer, or b is a non-negative integer. Any integer b, if it is greater than equal to 0, which means that it will have values like 0, 1, 2, 3, 4 like this, or b is a whole number. So if a is a negative integer and b is a whole number, then this will imply then obviously a will be less than b. So this was part 1 of rule 1. Part 2 says that it is the other way around, that actually part 2 is not required, part 1 is enough, but anyway, for the sake of completeness, let's say if it is the other way around, that is if a is a non-negative integer, that is a integer is greater than equal to 0 and b is less than 0, that is b is a negative integer, this will imply that a is greater than b. Okay, the rule 2 says, for example, let's take some example. We have a minus 2. If I consider a to be minus 2, minus 2 will always be less than 0. Minus 2 will be less than 0. Minus 2 will be less than 3. Minus 1 will be less than 0. We will have minus 1 less than 4, like this. Okay. What is rule 2? Rule 2 says that if both the integers a and b are non-negative, meaning that both the integers a and b are whole numbers, that is they are values greater than equal to 0. They are integers and their values are greater than equal to 0, like 0, 1, 2, 3, 4, 5, 6 like this, then definitely they are both whole numbers. So applying the concept of comparing whole numbers, you can compare a and b. So compare implies compare a and b as whole numbers. You already know how to compare whole numbers, so you apply that concept over here when both a and b are whole numbers. So for definitely we must have 0 is less than 2, 0 will be less than 4, 2 will be less than 3, 4 will be greater than 1, this way. Okay. What is rule 3? Rule 3 is a little complex, is a little relatively a little complex. So when both a and b are negative numbers, negative integers, so when both a and b are negative integers, how do you compare them? That is, both a and b are less than 0. A and b are integers and they are values less than 0, means they are negative integers. So the idea is that if mod a, you have to use the concept of absolute value of a and b. That is, basically you have to first compare them using their numerical value, that is their absolute value. And if you have the absolute value of a greater than absolute value of b, this will imply that a, the actual number a, will be less than B. And if you have the absolute value of A less than the absolute value of B, this will imply that A is greater than B. Why? So minus 1 is obviously greater than minus 2. First of all, let's try to understand this way. So my absolute value of minus 2 is 2, which is greater than absolute value of minus 1. Absolute value of minus 1 is 1 and absolute value of minus 2 is 2. So 2 is greater than, we are having 2 is greater than 2 is greater than, so minus 2 and minus 1, they are both negative integers and and we obviously have absolute value of minus 2 is greater than minus 1. So you can say that definitely it is obvious that so this implies that minus 2 is less than minus 1, which is true. As per the number line of representation of integers, you know that minus 2 is obviously less than minus 1. Okay. So minus 4, absolute value of minus 4 is 4 and absolute value of minus 9 is 9. So I can say that 4 is 9, 4 is less than 9. So absolute value of minus 4 is less than absolute value of minus 9, because absolute value of minus 4 is 4 and absolute value of minus 9 is 9. So we can say that minus 4 is greater than minus 9, which is true. Based on the number line representation of negative integers, if you know that the number minus 4 lies to the number minus the negative integer minus 9 lies to the left of the negative integer minus 4. Okay, so this is the concept. Whenever you have to compare two negative integers a and b, you have to compare by their absolute values. And if absolute value of a is greater than absolute value of b, it will mean that the value of a is actually less than value of b. And if you have absolute value of a less than absolute value of b, then the value of a will be greater than the value of b. Now, based on this concept of comparison of integers, you are often asked to arrange integers in ascending order. I have written down, you already know, you are already familiar of how to arrange integers in ascending or descending orders. But for the sake of completeness, I have written down the steps how you might be doing. Now, you may be doing in some other way. In my opinion, you can follow these steps. So for arranging integers in ascending order, that is ascending order means you arrange integers from smaller to larger values. So the step one, so you are given some integers. So step one is write all the negative integers first. So in the given list of integers, you first write down all the negative integers and then you write the 0. If there is 0 in the given list of integers, you write 0. And then you write all the positive integers. This is step 1. Step 2 is you arrange all the negative integers from smaller to larger. You arrange all negative integers from smaller to larger, and then you arrange all the positive integers from smaller to larger. Let's see with an example. Let's say you're asked to sort the integers minus 6, 4, minus 2, 3, minus 1 and 0. Let's say you are asked to sort the integers minus 6, 4, minus 2, 3, minus 1, 0. So if I follow the steps 1, 2 and 3, first I will step 1. If I follow step 1, I will write down all the negative integers first in the same order which is given in the original order, that is minus 6, minus 1, minus 6, minus 2, minus 1. Then I will write 0 if there is 0. So since there is a 0, I will write 0, and then I will write all the positive integers, that is 4 and 3. And now after step 2, in step 2 I will arrange all the negative integers from smaller to larger values. So this will be this is already in the negative integers minus 6, minus 2 are already in the order of smaller to larger values. Okay, so I have this. Now again, and then after step 3, I will arrange the positive integers from smaller to larger values, and after doing that, I will have the final order as 3 and 4. So this is the final order of the given integers in ascending order. That is, ascending order means smaller values to larger values. Okay. Now the concept, so the steps for arranging integers in descending order is the same, but since it's in descending order, the integers has to be ordered from larger to smaller values. So in this, the step 1, we write down all the positive integers first, followed by 0 if any, and then the negative integers. In the step 2, we arrange the positive integers from larger to smaller values. In the step 3, we arrange all the negative integers from larger to smaller. So let's say the same example. Let's take another example. Let's say we have 4 minus 3, 2, 5, 3 minus 2 minus 7 and minus 1. Let's say these are the integers. Let's say there is a 0. We have to arrange these integers in descending orders, that is from larger to smaller values. So I will write down all the positive integers first. 4, 2, 5, 3, and then I will write the 0 if there is any 0. Of course there is a 0, so I will write 0. Then after 0 I will write all the negative integers, minus 3, minus 2, minus 7 and minus 1. So this was after step 1. In step 2, I will arrange all the positive integers from larger to smaller values. So this will be, so these are the, so I have to sort these integers, these positive integers, that is 4, 2, 5, 3 from larger to smaller values, and this will be 5, 4, 3 and 2, and then I have the 0, and then the remaining negative integers. Now after step 3, in step 3, I will arrange all the negative integers from larger to smaller values. That is, I now have to order the negative integers from larger to smaller values. So after doing that, when after arranging all the negative integers from larger to smaller values, this will be minus 1, minus 2, minus 3 and minus 7. So this is the final order of the integers in descending order. Okay. Now let's solve few examples. Let's solve few example problems based on all the concepts that I have discussed in this video. That is about the collections of integers, the comparison of integers, the representation of integers on the number line, and the absolute value of integers. Now you can at this stage, whenever I will solve example problems, always pause the video and try to solve the problems yourself first, and then you can resume the video and see my solution. Okay. Question number 1 says, which of the following is always true for an integer a? Which of the following is always true for any integer a? Let's see all the choices. it says that mod A, absolute value of A plus A is 0. Now I have to see whether for any integer A this is true or not. If you can find some counter example, then that is fine. Then it will prove that this is not true. Now this is true. Please note that for if A is an integer, then absolute value of A plus A is equal to 0 will be true for all negative integers. This is true. This is true only for A less than 0, that is all negative integers. Because for example, you take absolute value of -2 and -2. What will be this? This is absolute value of -2 is 2 and we have -2 is equal to 0. So the option A, absolute value of A plus A is equal to 0, this will only be true for only negative integers. So A cannot be the correct choice because it says that which of the following is always true for any integer A. We have to choose that, we have to select the choice which is true for any value of integer A. So this cannot be the correct choice. Okay, let's see B. B says absolute value of A minus A is equal to 0. Again, this is true. This is true only for values of A which is greater than equal to 0. If A, the value of A, if A is greater than equal to 0, that is if A is non-negative integer, then only this will be true. This will be true. Now for the choice A, I have shown one example that A will be choice A will be true only for negative values of A. As you can see, as this will not be true for any non-positive integer. For any positive integer, you can see that if A is 2, absolute value of 2 plus 2 is equal to 2 plus 2 is equal to 4 is not equal to 0. So as an example, I just showed, I've just shown that if A is a positive integer, this statement of A, that is absolute value of A plus A is equal to 0, will be false. Okay. So choice B, the choice B says that absolute value of A minus A is equal to 0. This will only be true for only non-negative values of A, that is for values of A greater than equal to 0. As a counter example, let's say if A is negative, mod of -2 minus of A is -2 is equal to absolute value of -2 is 2 and we have plus 2 is equal to 4 and this is not equal to 0. So as a counter example, if A is -2, that is A is -2, this statement, that is absolute value of A minus A equals to 0, this is coming out to be false, as absolute value of -2 minus of -2 is coming out to be 4, which is not equal to 0. And this statement, absolute value of A minus A equal to 0, will only be true for non-negative values of A, that is values of A greater than equal to 0. So this choice is also not correct. Let's see C. Absolute value of A multiplied by A is equal to A square. Absolute value of A multiplied by A is equal to A square will be true, is true for A greater than equal to 0. This will be true only for values of A greater than equal to 0, that is for only non-negative integers A. As a counter example, let's say if A is a negative integer, mod of absolute value of -2 multiplied by -2, this is equal to 2 multiplied by -2, this is equal to -4 and this is not equal to -2 square. minus 2 square is equal to 4 and 4 is not equal to minus 4. The left hand side of the statement, that is absolute value of a multiplied by a, is coming out to be minus 4 if I consider a to be the negative integer minus 2, and a square will be minus 2 whole square, which is 4. So 4 is not equal to minus 4. So definitely this is not true for all integers a, as this will be false for all negative integer. Okay, so obviously all the choices a, b, c are not correct. So definitely none of this is the correct choice. None of this is the correct choice. Okay, let's see question number 2. An integer x is neither a positive integer nor a negative integer. An integer x is neither a positive integer nor a negative integer, so definitely it means it has to be 0. Integer x has to be 0. X is equal to 0. Then on the number line, distance of x from minus 4. So we have to find on the number line what is the distance of the integer x from minus 4. That is distance as we know. Okay, so distance of x equals to 0 from minus 4 will be equal to 0 minus 4. As we know, as we have seen, we have discussed that distance from x, if x is greater than, if x is less than y, if x and y are two integers and x is less than y, then on the number line, then the distance of y from x, or the distance between x and y on the number line will be y minus x. So in this problem, x is 0 and it is asking what will be the distance of the two integers 0 and minus 4, and obviously it will be 0 minus, since 0 is greater than minus 4, so it will be 0 minus of minus 4, which is equal to 4, So the correct choice is C. C is the correct choice. Okay, let's see question number 3. The integers a and b, a not equals to b, on the number line are at the same distance of d from the origin. The integers a and b, a is not equals to b, so a and b are two different integers, and on the number line they are at the same distance of d from the origin. So if we have, this is the number line and this is the origin O 0, it is saying that a is not equals to b, a is not equals to b, and on the number line the distances from the origin O is same, which is d. So obviously one number, so the integers a and b are on the opposite side of the origin, then only they can have the same distance. So let's say a and b mark the integers, let's say small a and small b. So small a is marked on the number line by the point a and small b is marked on the number line by the point b. Now it is possible that a, so this means that a is less than 0 and b is greater than 0. It could also be the other way around. A could be on the right hand side and b could be on the left hand side, but that will not make any difference in the solution. So we have this distance is d, and also this distance is d. Now what does it mean? So okay, d, then which of the following statement is necessarily true? Then which of the following statements is necessarily true? Now if I consider b to be on the right hand side of the origin O, that is if b is positive, then a will be negative, and if the distance of b, that if the distance of the point capital B from the origin is small d, this will imply that uh, this will imply that A has to be equal to minus B. A has to be equal to minus B. That is, A and B are negative of each other. A has to be equal to minus B. Or I can say, it's better I say, if I know that B, if the distance of the point capital B from origin is small d, and if the point capital B is representing the integer b, I can say that b is equal to d, and a will be equal to minus of d. D is the distance. The distance is always a positive value. So and since we are assuming that A is on the left hand side of the origin O, say A is negative, so we are having A must be equal to minus D and B must be equal to D. So this is one scenario where we are assuming that B is positive and A is negative. So in that case, it must be that B is equal to D and A is equal to minus D. So in this case, let's see which of the choices are is always true. The problem is saying then which of the following statement is necessarily true. So let's see. So mod of absolute value of A plus B, let's find out. This is A is minus D, and we have B is D, which is equal to absolute value of 0. Absolute value of 0 is 0. So this is not equal to twice D. This is 0 is not equal to twice D. So definitely this choice is not correct. Let's see what is choice B. It says that mod A, absolute value of A plus absolute value of B is equal to D. Let's see. Let's find out what will be absolute value of A plus absolute value of B. So this is A is minus D and we have B is D. So this is equal to absolute value of minus D is D and absolute value of D is D. So this is twice D, and which is not equals to D. So therefore this choice is also incorrect. Okay, let's see choice C. Absolute value of A multiplied by B will be equal to absolute value of A is minus D and B is D. This is equal to absolute value of D is D, and absolute value of minus D is D, and this is D multiplied by D is equal to D square. So this seems to be a correct choice. That is, absolute value of A multiplied by B is coming out to be D square. Now now we have to, now this is one scenario when we have considered A to be negative and B to be positive. Now the other possibility is that B can be on the left hand side and A can be on the right hand side. So this means that B will be equal to minus D and A will be equal to D. Now, so these are the two possibilities of the values of A and B. Now the choices A, B and C, the choices A and B we have seen is already incorrect if B is equal to D and A is equal to minus D. So definitely choice A and B will be incorrect. But let's see, so but the choice C is correct only only when we have seen that only when we are having A is equal to minus D and B is equal to D. What if let's try to verify the choice C if A is equal to D and B is equal to minus a D. So absolute value of A multiplied by B when A is equals to D and B is equals to minus D is D multiplied by minus D. So this is D multiplied by minus D. This is equal to minus D square and this is not equal to D square. So we see that the choice C will not be correct if A is equal to D and B is equals to minus D. That is if A is positive and B is negative. So in one scenario for the choice for the choice A equals to D and B equals to minus D, the choice C is incorrect. We have to choose the choice which will be correct in any scenario, that in any scenario, that meaning that in both the scenario, that is when A is negative and B is positive, or when B is negative and A is positive. In both the scenario, the choice which is true in both the scenario, that choice should be the correct statement. Okay, now let's see the choice D. Let's see the choice D let's see if the choice D is correct or not if A is equal to minus D and B equals to D. So we have absolute value of minus A plus minus B. This will be equal to absolute value of minus A. Now what is minus A? Minus A means minus of minus D, and we have B is D, so minus B is minus D. So this is equal to absolute value of minus D is D, and we have minus D. This is absolute value of 0 is equal to 0. Okay, so when A is negative, that is A is minus D, and B is positive, that is B is D, we are seeing that the choice D is correct, is a correct statement. Now what if what will be absolute value of minus A plus minus B if A is positive and B is negative? In that scenario, this will be minus A will be minus D and minus B will be minus of minus D. This is equal to absolute value of minus D plus D, which is equal to absolute value of 0, which is equal to 0. So we see in both the scenarios, that is when A is negative and B is positive, and when A is positive and B is negative, the statement D is always true. So the correct choice is D. D is the correct statement. Okay, let's see question number 4. For an integer x, if mod x is equal to x, then x must be non-negative, non-positive, 0 or positive. So we are given that mod x is equal to x, and x is an integer. So what can we say about the integer x? Is it 0? Is it non-negative? Is it non-positive? Or is it positive? Mod of x is equal to x. Now please note that mod x is always non-negative, is always non-negative integer, that is the absolute value of any integer x will always be greater than equal to x. That is, we must have absolute value of x is greater than equals to x. Now it is given that absolute value of x is x. So we must have, this implies that we must have x must be greater than equal to 0. So this implies that x is non-negative is x is non-negative integer. That is, the correct choice is A. A is the correct choice. X must be a non-negative integer. Now, you cannot say the choice C, because it is not the case that mod x absolute value of x will be x only for 0, only for the value of x to be 0. No, it is not the case. If you take any non-negative integer, if you consider x to be any non-negative integer, meaning any integer which is greater than or equal to 0, let's say 1, mod of 1 will be equal to 1. Mod of, you take any non-negative integer, that is any integer greater than or equal to 0, greater than or equal to 0. So obviously mod of absolute value of 0 is equal to 0. Absolute value of 3 is equal to 3, but this will not be true, that is absolute value of x is equal to x. This will not be true for a negative integer of x. So absolute value of minus 2 is equal to 2, and this is not equal to minus 2. So as you can see that this statement, absolute value of x is equal to x, will always be true when x is a non-negative integer. So the correct choice is A. Let's see question number 5. Based on the number line below, state whether the following statements are true or false. Okay, so we are given some integers, some negative integers, minus 6, minus 4, minus 2, and some positive integers 2, 4, 6, and some points are marked in between. So from the number line, it is clear that, okay, so we have this number line. This is the center O, 0, we have 2, we have 4, we have 6. So definitely the point B is midway between 4 and 6. So definitely B is 5. The point E is midway between 2 and 4. So definitely this will be 3. And we have minus 2, minus 4, and minus 6. So definitely the point D is midway between minus 6 and minus 4. It must be minus 5. And we have A. Okay. So this is the number line given. Now let's see, we have to verify whether the following statements are true or false. There are 10 statements. Okay. Let's see. D is a non-positive integer. So non-positive integer means that D is negative, that is D is less than 0. So what is D? D is equal to minus 5. This implies that D is non-positive. All negative integers are non-positive. Non-positive integer. D is a non-positive integer. Sorry, D is a negative integer. D is equal to minus 5. D is minus 5. This implies that D is not non-positive, but D is negative. D is negative. Non-positive integer means that it is not positive, which means that it can have the value greater than or equal to, it can have the value less than or equal to 0. So 0 is also a non-positive integer. Also all the negative integers. So D is non-positive integer. So we must have, this statement is false because D is minus 5, which means that D is a negative integer, but it is given that D is a non-positive integer. So this is false. Okay, let's see 2. Absolute value of D is greater than B. So what is absolute value of D? Absolute value of D is minus 5. So this is absolute value of minus 5. This is 5. And what is B? b is equal to, from the number line we can see b is equal to 5. So this implies that b is 5, and we know that 5 is not greater than 5. So this implies 5 is not greater than 5 cannot be 5 is not I can say that 5 greater than 5 is false. So this statement is a false statement. Absolute value of d is 5, so 5 cannot be, and the value of b is 5, so 5 cannot be greater than 5. 5 is equal to 5, so this is false. This is false. Part 3. Between a and e there are 6 integers. Between a and e there are 6 integers. Okay, now what is a? A is equal to 4, and what is e? E is equal to 3. So how many integers will be there between a and e? Number of integers between a is not 4, but a is minus 4. Sorry, a is minus 4 and e is 3. So number of integers between a and e will be equal to, the formula was y minus x minus 1, where x is less than y. So here y is 3 and x is minus 4. So it will be y minus x, that is 3 minus of minus 4 minus 1. This is equal to 7 minus 1, which is equal to 6. So it is given that, it is saying that between a and e there are 6 integers, which is true. So this is a true statement. Okay, let's see part 4. Between d and b there are 5 integers. So let's see what is d. D is equal to the value of d is equal to minus 5. D is equal to minus 5 and b is equal to 5. So between number of integers between d and b is equal to okay, so this will be equal to 5 minus 5 minus 1. This is equal to 9. Between d and b, it is given that there are 5 integers. Between d and b, what is d? D is minus 5 and b is 5. So number of integers between d and b will be b minus d minus 1. Okay, so this is definitely a false statement. Between d and b there are 9 integers. Okay, let's see part number 5. Absolute value of a minus e is equal to b plus 1. Absolute value of a minus e is equal to, what is a? A is minus 5 minus e. A is minus, a is minus 4. A is minus 4 minus a minus e. So a is minus 4 and e is 3. So absolute value of a minus 3 is absolute value of minus 4 minus 3, which is absolute value of minus 7, which is equal to 7. And what is b plus 1? B plus 1 is equal to, what is b? B is 5. 5 plus 1 is equal to 6 is not equals to 7. So this is a false statement. Five is a false statement. As we can see that 6 is not, absolute value of a minus e is coming out to be 7, and the value of b plus 1 is equal to 6, which is not equal to 7. Okay, let's see the part 6. It says that a is less than d is less than 0. A is equal to, what is a? A is equal to minus 4. What is d? D is equal to, from the number line we can see d is equal to minus 5. D is equal to minus 5. So these two implies that d is less than a. D is less than a. So definitely it is a false statement. It is given that a is less than d, is less than 0. But we can see from the number line that a is greater than d. D is less than a means d is less than a means a is greater than d. So this is definitely a false statement. 7. Absolute value of a multiplied by b is less than absolute value of b multiplied by a. So what is absolute value of a multiplied by b? A is minus 4. So absolute value of minus 4 multiplied by b, what is b? B is 5. So this is equal to absolute value of 4 minus 4 is 4. 4 multiplied by 5, which is 20. So this 20 is the value of absolute value of a multiplied by b. Now what is the value of absolute value of b multiplied by a? This is absolute value of 5 multiplied by minus 4. This is equal to 5 multiplied by minus 4. This is equal to minus 20. So clearly we can see that we can see that mm, 20 is greater than minus 20. 20 is greater than minus 20. This implies that absolute value of a multiplied by b must be greater than absolute value of b multiplied by a. So it is a false statement. The given statement is a false statement. Since it is given that absolute value of a multiplied by b is less than absolute value of b multiplied by a, but it is false, as we have found that absolute value of a multiplied by b is greater than absolute value of b multiplied by a. Let's see 8. It is saying that b is greater than e is greater than a is greater than d. Okay, that is if we arrange the numbers integers a b e d, then in descending order it will be b e a d. Let's try to see what will be the descending order of the integers a b e d. So a is equal to what is a? A is equal to minus 4. B is equal to 5, and a b e d. Okay. So d is equal to minus d is equal to minus 5, and e is equal to 3. If we want to arrange the numbers a b DE in the descending order, what will be the order, what will be the arrangement? So definitely the largest value of the numbers A, B, E, D is 5, that is B will be the largest one. The second largest one will be 3, which is E. The next largest one will be A, that is -4, and finally the smallest will be D. So this is a correct statement. So as you can see, this is a correct statement. The given arrangement, it is given that B is greater than E is greater than A is greater than D. It is a correct statement. Okay. Let's see part 9. It is given that absolute value of D minus, again absolute value of minus D is equal to 10, is equal to given to be 10. Let's find out what will be the value of this expression. This is a little complex expression regarding absolute value. So this is absolute value of D minus, and again we have absolute value of minus D. So this is, if we put the value of D, what is D? D is -5. D is -5 minus, again absolute value, negative of D, that is -5. Okay. So this is equal to -5 minus, we have to find minus of -5 is 5. So absolute value of 5 and again absolute value. So this is equal to -5. Absolute value of 5 is 5. So this is -5 minus 5. So this is absolute value of -10, which is equal to 10. So this is a correct statement. This is a correct statement. Let's see part 10. Minus of B is greater than minus of D. Let's see what is minus of B. What is B? B is what is the value of B? B is 5. So this is -5. Okay, which is equal to -5. And what is D minus 1? D minus 1 is equal to, what is D? D is equal to D is equal to -5. D is equal to -5. So -5 minus 1 is equal to -6. So we know that -5 is greater than -6. So this implies that minus of B is also greater than D minus 1. So this is a true statement. Part 10, it is a true statement. Okay. Let's see the last problem, which is question number 6. For an integer a, when the numbers a plus 2, a minus 1, a plus 1 are arranged in the descending order, if the last number in the order is x, then the value of absolute value of x minus a is, okay. Now a is an integer, we don't know what is its value. Whatever that integer a be, we can clearly say that for whatever integer a be, the value a plus 2, if we add 2 to an integer a, it will be more than the value a plus 1. A plus 2 will be greater than a plus 1, and a plus 1 will also be greater than a, and a will be greater than a minus 1. So this is, so if we arrange the numbers a plus 2, a minus 1, a and a plus 1 in the descending order, this will be the order. And the last number in this order, in the descending order, will be a minus 1, which, so we must have x is equal to a minus 1. So this implies absolute value of x minus of a is equal to absolute value of what is a, x is a minus 1, and we have minus a. This is equal to absolute value of A cancels out, absolute value of -1, and this is equal to 1, and hence the correct choice is B. B is the correct choice. So with this, it comes to an end in part 1 video, where I have discussed about the concept of the various collections of integers, that is all the sets, standards, all the sets of integers, and we have discussed about some fundamental concepts of all the integers, of the various types of integers, and the number line representation of integers, and the absolute value of an integer, and the comparison of integers, how to arrange integers in ascending and descending order, and we have solved few problems based on these concepts. I hope this video will be beneficial to you for understanding all these concepts and apply them to solve this kind of problems. If this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will discuss about the addition and subtraction of integers with some example problems. Okay. So once I will complete the whole chapter of integers, I will start solving and discussing about relatively harder concepts on this chapter of integers in the other playlist, that is Maths 7 Hot. So please keep an eye on that playlist also. I will end the video here. Thanks for watching, and until the next video, take care and bye. And also please feel free to leave any comments if you have any suggestion for how I can improve my videos, or if you have any specific question on the topics discussed in this video, or if you have any other queries related to how you want my videos to be. I will highly appreciate that. Thanks for watching. Until the next video, take care and bye.